Assalamualaikum and hi, I'm Nurul Hidayah. The topic of my presentation is about the effect of chemical warm asphalt additive on the writing characteristic of each binder containing waste engine oil. My presentation is divided into 4 main sections, which will cover on the introduction, materials and method, results and conclusions. For introduction, I will give some short overview of this study. At the end of service life of asphalt pavement, the road surface can be recycled by milling process. This material is known as reclaimed asphalt pavement or RAP. During the service life, this RAP is exposed to the environment such as oxygen, ultraviolet radiation, change in temperature and traffic load. All these factors contribute to the aging and stiffen the edge binder in RAP. The stiffness of edge binder can contribute to the workability problem. Waste engine oil is one of the material that able to rejuvenate the edge binder. On the other hand, warm mill asphalt technology is reported able to improve the workability of each binder. Based on the literature review, very few studies have been carried out on this emerging technology. Hence, this study focused on the effects of introducing warm asphalt additive to the writing characteristic of each binder containing waste engine oil. This table shows the detail of the testing sample used in this study. About 15% of waste engine oil was used, which is based on a previous study, was blended with chemical warm asphalt additive at 1%, 2%, and 3% by weight of asphalt binder respectively. After the blending process, the samples were tested with dynamic shear rheometer or DSR. There are two parameters used for writing characteristics. First is the writing resistance by the G star or sin delta over sin delta. Second is the creep recovery. For writing resistance, the test temperature is about 64 degrees Celsius and the creep recovery at 60 degrees Celsius. Next, we move to the results section. Compact modulus, G star, and phase angle is the basic properties in DSR. G star represent the stiffness, meanwhile the phase angle represent the elasticity of asphalt binder. As can be seen, the compact modulus of asphalt binder, which contain each binder and waste engine oil, is higher than binder A. Binder A is the base binder that used as reference. In the modified binder, the addition of chemical warm asphalt additive reduce the stiffness or G star of asphalt binder. Meanwhile, the phase angle of modified binder is lower than binder A. This indicate the enhanced elastic behavior, which means that lower phase angle is desirable because it reflects more elastic component. Second parameter is G star over sin delta or writing resistance. The writing resistance of modified binder is higher compared to the base binder of A. The addition of warm asphalt additive was found to reduce the writing resistance. At 1%, the writing resistance is reported as 10.09 kPa. With the addition of 2% chemical additive, the writing resistance reduced to the 8.46 kPa, and at 3%, the writing resistance was reported as 6.12 kPa. The last parameter is creep compliance. Creep compliance usually used as a deformation indicator in creep tests. The lower value of creep compliance indicates higher writing resistance. It was found that the warm asphalt additive Improve the deformation resistance of each binder containing waste engine oil. The lowest creep compliance was recorded by BC2. Meanwhile, the binder A showed the higher creep compliance. As a conclusion, the results show that warm asphalt additive could be applied with each binder in waste engine oil, but at the amount of not exceed 2%. This is to ensure the blending binder still has sufficient stiffness and elasticity to resist the rutting. That brings me to the end of my presentation. Thank you for your attention.